So in today's lesson, we're going to be going over how to balance redox reactions in alkaline or basic conditions. Basically, you've already done most of the dirty work here because you've learned how to balance in acidic conditions. So to start off a question that asks you to balance in basic conditions, you're going to perform all of the steps with the acidic solution, except, you're going to add a couple of extra steps. Not after combining half reactions, but before combining half reactions. Okay, so take a minute as a practice exercise to go ahead and balance these up to the point where you're ready to combine the half reactions, but you haven't yet. Go ahead and do that. Pause the video, try that out on your whiteboard or in your notes, and then come back and we'll take it up together. Okay, so I'm going to center this just because it'll give me a little bit more real estate. I'm going to start by separating out these half reactions. So IO3 minus goes to make I minus, iodate goes to make iodine, and then I have my oxalate, C2O4, 2 negative, going to make carbon dioxide. Okay, and so I'm going to start by adding waters if I need to. So I'm noticing right away that my oxygen here, I have 3 of them, and so that means I need to add water to the product side. So I'm going to add 3 waters to create those oxygens, to balance those oxygens. And now that puts me in a situation where I need to add 6 hydroniums on my reactant side. Okay, I'm going to go ahead and balance my charges now by adding the correct number of electrons in. So here I have 6 positive charges and 1 negative charge, giving me an overall charge of positive 5 on my reactant side. And then I do the same on my product side. I have negative 1 and 3 neutrals, which gives me an overall charge of negative 1. Right? And so that means that I need to add electrons in to balance all of this out. And so what I'm going to go ahead and do is I need to add 6 electrons in to balance the charge, to give me an overall charge of negative 1 on my reactant side. Now, let's take a look at the second reaction equation. I'm hoping you noticed that there were 2 carbons on the reactant side, so I need to balance my carbons first. And so when I go ahead and do that, then I notice that life is a little easier because I've got, 4 oxygens and 2 times 2, 4 oxygens. So my oxygens are balanced, so no need to add water in that second half reaction. But I still need to balance the charges. So I see that I have negative 2 charges over on my reactant side, and I have neutral on my product side. So I need to balance out that by adding in 2 electrons on my product side. Okay, and so this means that I need to balance out my charges because I have 6 electrons here and 2 electrons over here. So I'm going to go ahead and I'm going to multiply the second reaction by 3, and then I'm going to rewrite that equation. I'm going to rewrite both of them actually. Let me see. I've got 3 oxalates reacting to make 6 carbon dioxides plus 6 electrons. Okay, I'm going to take a quick pause to copy and paste those into the next section so we can look at the additional steps we would need to take in order to balance this in basic conditions. Okay, and so I've got this all set up to go. And so what I've done is I've just sort of copied and pasted the half reactions where we left off. And so the next step is to add as many hydroxides to both sides of the reaction as there are hydrogen. And you'll remember that hydrogen ions are responsible for acidic properties, and hydroxide contributes to the alkaline or basic properties of a solution. So I'm going to go ahead and follow the instructions here. And it says that I should be adding as many hydroxides as there are hydronium to both sides. So I'm going to add in 6 hydroxides and then 6 hydroxides over here. Now there's nothing for me to do in my second half reaction because of course I don't have any hydrogen ions. Now, I want you to take a minute to think about, well, what should we do here with these hydrogen and hydroxide ions? Well, if you read ahead, then you know we have to combine those to produce water. So my next step is going to be to take these guys and make them into water. So that will be my next step. Let me go ahead and write that out. So I've got now 6 electrons plus 6 waters plus 1 iodate ion. I'm going to make iodide, I should say, plus 3 waters and then 6 hydroxides. Now I'm just going to go ahead and copy out my next half reaction as well with the oxalates and the carbon dioxides and the electrons. No, I'm pretty much done here. I've added the hydroxides in, and then I've combined them to make water. So that's this guy right here. Now I'm going to do what should probably come as intuitively to you, which is to cancel and then rewrite. So let's look and see, well, what can we cancel here? I can see I have 6 waters here and 3 waters here. So I can cancel out the 3 waters here and replace them, and that leaves only 3 left over here. And I can cancel out my electrons, obviously. Now I just want you to be aware, because in many reactions, the second half reaction will also have some hydroniums and some hydroxides and some waters that need canceling as well. So just be aware of that. All right, so I'm going to write out my combined reactions here, which should be 3 waters plus iodate plus 3 oxalates reacting to make iodide plus 6 carbon dioxides plus 6 hydroxides. There we go. And so there we have it, folks. That is how you balance a redox reaction in basic conditions, just a couple of extra steps.